Yeah, I think that's what we said. Isn't that what we said? Yeah. Okay, good. Thanks for the independent confirmation. Good job. Okay, so since I've got to put this computer over here, y'all have to glance back at it every once in a while, see if there's any comments, and make sure it's still doing things so that the people that are missing are not like, oh my gosh, it stopped halfway through the recording.
Like what I did last week, except for it was just a blank whiteboard the whole time.
I hate it.
Yeah, it was like that one.
We hate it.
What's it got in its pockets? Did you know that the ring that Gollum had, being the One Ring, was a retcon? In fact, not only was it a retcon, but it was like the original published Hobbit didn't have that idea in it at all, and then it was a later published version put it in there.
Wait, know that. So
Grandpa Tolkien liked to change the way things worked.
So what happened in the first?
It was similar. It was still a ring, still turns you invisible, but it wasn't the One Ring.
It was just a ring.
Not original. It was, yeah.
It was a ring of power.
Not the.
Okay, what problems did we assign?
8 through 26.
Oh, we're also going to need television, aren't we? Because they're like pictures, right? Yes. Graphing rational functions.
Rat. I'm gonna need to study more of this.
And we did, what did y'all say, what numbers?
8 through 26.
8 through 26. All right, let me take a picture, go turn the TV on and see what happens.
We changed the channel, right?
We did change the channel
Goodness.
Why? What happened?
because it was a little weird.
You got free pizza.
There was something strange happening between two people and it was confusing.
Yeah, axes are cool.
That's way better than whatever the heck it was. Probably.
Yeah.
That guy is so annoying. Fortune Fire is a great show, but that guy is so annoying. Will it kill? Shut up, moron. You're not cool. Stop trying to be cool. No, it's a blacksmithing show.
They make knives and stuff and they chop.
Stuff as he goes and sees whether it'll chop through pigs or whatever. Oh gosh, not that. I almost made a giant mistake because I was talking. Yeah, I'm sure he had a great time.
These are so weird. How do they do that?
Okay.
I missed so many.
Number 10, right there.
No, 8.
8 is also, no, I didn't mean 8, I meant 10, but y'all wanted 8, and there's 8.
Why is it flat on top?
Because it doesn't touch that axis. Okay. Number 10, big fat head. $12A is right there. Ooh. $12B is $10.68 and $9.95. And 12C is more than 885. And for 14 through 26, let me turn the page. Number 14 is right there.
What's that? 4. I did that one.
Number, hello, 16 is that guy.
Yep.
18 is this way.
What? See, I didn't understand that problem and I photomapped it and it looked like that, but I didn't understand why it looked like that. And I had to pay money to see the explanation. So I didn't
How
know that.
rude.
You had to pay money to see the explanation.
You want to know what you should have tried? You ready? What you should have tried next? is you should have taken a picture of it and put it into Gemini and asked it to explain how to do it. They would have done it for free.
I don't know what Gemini is.
It's another AI. Yeah.
School AI.
Yeah. Or you could have put it into Grok and it would have done the same thing, probably, if I had to guess. I have just started playing around with Grok, and it is flipping amazing for math stuff. Like I used it to help me make a pre-cal test, and it was incredibly good.
Those are a little blurry.
Yeah, it's so sad.
It's okay, we can see good.
You can see enough to tell what you need.
What is this one, 24?
Yeah. No, it's 22.
Okay, that's what I was
24 looks like this guy.
Yeah. Oh, I did it in the wrong way because I did it.
And finally, 26 looks like that guy.
Why? We need this one.
Okay, so while we flip the camera around, what questions do we have?
18.
Or maybe it was 18.
18. 18.
Oh, no, 18.
Lots of people asking for 18s. Let's definitely do 18.
I'm on the wrong one.
Beautiful. Okay. Connect, church. I was answering Lillian's question for like an hour and a half ago. That's where the craft fair is going to be, at Connect Church. 18.
Delayed gratification.
F of x equals 2x over x plus 2 times x minus 5. Okay. So, what do we need to know about it?
How it transforms.
Well, the parent function, these people don't really have parents exactly. They're a little bit crazy. Where's the remote? Oh, right there. I found it. So what is this going to look like? What is it going to have? It's going to have at least one asymptote, right? It could have multiple asymptotes. So how do we figure out what types of asymptotes are there? That's always a good place to start on these problems is what...
The degree,
Oh my gosh.
right? The degree.
No, what kind of asymptotes are there? There's a vertical one, I just gave you that one. What other kinds of asymptotes?
And a diagonal.
Yeah, and then we figure out what they have by the degree.
Yeah. I thought you were asking like which specifically that one had.
Ah,
So I was saying we needed the degree.
horizontal, slant. Does it have vertical asymptote?
Yes.
The answer is always yes. It always has at least one vertical asymptote, right? How do we figure out where the vertical asymptote is? Our asymptotes. Look at your notes. I mean, like you should have been doing like the whole idea of this, guys, is that you do the homework, so you should be able to answer that question, even if you don't get this problem right. If you've done the homework, you will have engaged with it, and you would have done that multiple times, yes? How do we determine whether it has a vertical asymptote, or where the vertical asymptotes are?
I just don't remember which exactly because I looked at these.
Yeah,
It
there's like
has
2.
one.
How do we find out where they are?
The top.
No.
I thought it was from the X being on the.
Oh, it's at 2 and 5, or negative 2 and 5, because that's what
So what did you actually do to do that?
because
What is this part of the fraction called?
the
Denominator. Yeah. What do you do with the denominator?
You divide.
Take the number and make it for where it does for the line at the.
You set it equal to 0. And when we set it equal to 0 and set each factor equal to 0, we end up with x equals -2 and x equals 5. So it has vertical asymptotes at x equals -2 and x equals 5. Great. That's a great thing. How do we figure out whether it has a horizontal asymptote?
From
There are.
the top.
So this is where you were trying to answer a minute ago. You're comparing the degrees, right? The degrees of the numerator, the degrees of the denominator. So what is the degree of the numerator? 1. What is the degree of the denominator? 2. So the degree of the numerator is 1 less than the degree of the denominator. So what does that tell us?
It will have
It's going to have a slant asymptote is what you're telling me. Is that right?
Or I thought it was if the degree is top is more than.
Does it matter? If like one.
It does matter. So the let me say some different words. The numerator is less, the degree of the numerator is less than the denominator. What does that tell us?
The top is
What?
The top is less than the bottom one?
Yeah, the top is less than the bottom one. The numerator is less than the denominator. What does that tell us?
then it'll be
You should have notes on this from last class.
It makes it have the 3, right?
What?
It makes it have like the 3.
No.
The top is, oh wait, that's at the bottom.
If the degree is, then there's no horizontal axis.
If the degree of the numerator is less than the degree of the denominator, is that what you wrote? Is that what's true?
The top is less.
Or yeah, it's the other one.
Yeah. So it has a horizontal asymptote at y equals 0.
Yeah, I just read
Great.
the wrong one.
So does it have a slant asymptote? When would it have a slant asymptote? It doesn't, but when would it have one?
Has one less, the top has one more than the bottom.
Has the top has one more than the denominator. The numerator has one more degree than the denominator. Right. Great. So we got these and these. So let's sketch out what we know so far, right? That's easy money.
How did you get the y equals 0?
Because the degree of the numerator is less than the degree of the denominator. And at -1, 2, we've got an asymptote.
So can you have 2 vertical asymptotes and a slant one?
Yes. Great. So now what should we do? Make a table sounds like a great idea. What do we want to put in our table? Between them and to the left and the right of them. We need to know what's doing in all 3 of those chunks.
So we need like 2 numbers from each chunk.
At least. 2 is probably a fine place to start. We might need more than that.
Do the 3 like
negative 3 and negative 6.
Negative 6, negative 3.
No, nobody cares.
Can we do 0?
We could do a 0. Now what else could we do?
A 1.
1 sounds fine. What else could we do?
6.
6.
Sounds great. What else?
7.
Let's do a little bit further. Yeah, how about an 8? That's great. So f of negative 3. So negative 6 up here. Negative 3 plus 1 plus 2 is negative 1 times negative 8.
So it makes it 8.
So it makes it positive 3/4. Negative 3/4, excuse me.
No, yeah, no, yeah, you're right, it is.
Negative,
Negative 6
3.
and negative 9.
That's not 9.
Oh, yeah, that's 8.
It's a negative
I
3/4.
was thinking add them instead.
Great. So negative 6.
Negative 4 and
In the numerator, we've got negative 12. In the denominator, we've got, negative 4 times negative 11. So that equals negative 12 over 40. Wow, that got exciting. Over 44, so 6.
622.
3 over
3/11ths. 3/11ths. Okay.
Negative.
So, yes, negative 3/11ths. I can already see that we really need one more point here, right? Because we know what it's, we knew that it was going to get closer. We also know that it's down here, right? Right, because they're all negatives. So it's going to get closer and closer to this asymptote. We knew that, right? So we need a point that's like over here to see kind of how quick the bend is, right? So we have this point, negative 3/4. So something like right there, right, is what we already have. We need something here, in here, to see what it's going to do. Is it going to, it shouldn't jump up there, but is it going to go real fast here? Is it going to, how quick is our bend? Yeah? So what point can we pick in here?
Negative 2.5.
Negative 2.5 or negative 2.5, however you want to say that word. That sounds great. So in the numerator, we have negative 5, right? Over negative 1/2. And
positive 7.5.
negative 7.5.
Yeah, negative 7.5.
Which equals negative 15 halves. So positive 15/4, right? I'm just doing math. Punch it in your friggin' calculator. You got this. Yes?
Oh, I got it.
Good. Good, good, good. Think about, instead, let me give you some advice. I've been trying to give this advice to multiple classes, not just y'all, also Algebra 1. What you should be, I'm going to try, hopefully shift some thinking a little bit to see if we can get more use out of being in class when I am in class. What you should be doing, whether I am doing this on recording, whether I'm doing it live, what you should be doing is you should be thinking about what I should do instead of what I did do. Does that make sense on the difference?
When I was doing it.
Well, and that's okay. That's okay because see here, no, doing it wrong is good. We like doing it wrong in class. That is good because then you're like, oh, this is what I should do. And then you don't do it that way again. If you wait and try to figure out what I've done, you're not going to remember what to do, like ever. Like ever. Because you didn't you see what I'm saying? We like getting wrong things in class. That's the right time to get it wrong. Okay. We don't even mind getting things wrong on a test as long as we still use that as a learning experience. We don't really care, right? That's still doing things. I can still see the back of Malcolm's head. Am I in the screen or is it frozen? It might be frozen. Nobody checked. Oh my gosh, y'all are letting people down.
I can barely even see the screen.
Oh my gosh. You can. You would just have to move.
I'm fine.
I know.
That's what
Yeah. But yes, you're right. Good job. 15/4, so it's going to be 20/15, and then reduce that, right?
That would be 4/3. So 1 1/3.
Look, I can't even see Malcolm's head anymore.
is that 1/2 or
Oh, no.
something in 1/2?
Okay.
We can have that frozen.
What is?
That first number is just 1/2, right?
Yeah, -1/2.
Did it freeze again?
There's just a lot of
Okay. There's a lot of what?
smudges.
Oh, I thought you said smooches. I was really confused. I didn't draw any kissy faces on the whiteboard. Why would there be kissy faces?
It's a whiteboard.
So 20/15, so negative 4/3, negative 1 1/3. Great. So that's plenty over there, right? It's going to do what we thought it was going to do, right? It's going to go. Okay, great. So now let's go to the middle. So let's do f of 0. It's going to be 0. Great.
No.
Because 2 times 0 is 0, and it's not going to break any of those. Let's do a 1. So f of 1.
1 over.
No, 2 over. Over 3 times -4.
Wait, what am I doing?
I don't know. Is negative 1/6. Because the denominator is going to be negative. F of 6. It's going to be 12 over 12 plus 2 is 8 times 1. So 6/4, 3 halves, 1 1/2.
Couldn't keep up.
That's okay. You got to practice. Practice makes permanent. Not perfect. Practice does not make perfect. Let's chuck an 8 in there. See what happens. I can already see that there's a chunk of this that we are definitely going to want to get some more points.
16.
Yes, 16.
16
Good job.
10. Did I get something right? 10.
Look at you. Look at you. Times 3. So 16/30ths, which is 8/15ths, right? Okay, so this chunk and this chunk, we've got pretty good idea of what happens. Yes? This chunk and this chunk, we can see this one's going to be like this. Yeah, with the we. This chunk, I would argue we're fuzzy. Yeah, we've only got a couple points in there, and 0 0 and 1 -1/6. So it's going to be like this. But what else does it do? We probably need a little bit more in this information in this space. This one we've got 6, 1 1/2, 1 1/2. So right there-ish. And then we've got 8, 8/15. So as we expected, it's going to get closer and closer to the axis. So it's going to go like this. Yes?
Thought this one looked fun.
Right? That's easy money. Now, we don't got enough information in here. We need to figure out, because we just got 2 dots. Does it go like this? Does it go like this? What does it do? So we need something else here. What else we want to put in here?
3.
How about we put in 2 and 3 and maybe even 4 for good measure. Actually, you know what we should do? Instead of the 4 for good measure, let's do -1 for good measure, right? To the left of our dots and to the right of our dots, and that's probably plenty to be getting on with. All right, so f of 2, negative,
2 times 2 is 4.
no, 4, right?
4, yeah.
Or
2
do we
times
do
2 is.
We're doing,
I
mhm.
guess
Yes, yes. If we were doing, yeah, this would be -2. Yes, yes, yes,
I think
yes.
I need to clarify something. 2 times 2 is 4.
No, you don't need to clarify that at all. You, in an effort to rush forward and tell your joke, you didn't realize that we were like all caught up and beyond that. But it's okay. You told a funny joke. Okay, moving on.
-1/3.
It is 4 times what? -3? 4/12, which is 2/6, which is 1/3.
-1/3.
You're right.
I was right first.
2 and then 1/3. Oh, we're getting a much better picture. It's probably going to go something like that, but we'll see. Or we've made a mistake, but this will also help us figure that out. f of 3. Yeah, +6.
Positive 5.
5 times
-2.
-2.
6 over
So
negative.
-3/5.
Dang it, you beat.
So 3, -3/5. Oh, so I was probably wrong. It probably doesn't. Oh, it's gonna be like a little,
It's the weird design.
I don't even know what it is. Let's find out. Keep going. There, right there. f of -1.
-2.
-2 and 1 times -6. So +1/3.
Now we should graph the thing.
Probably so. Let's take a look and see what we got. We probably don't have enough yet.
What is the shape?
Oh, it's going to be like, we need to figure out end behavior. So we need something like, this is going to be here. So we need this, and we need something way over here. So we need some halves. We need like a -1.5
4.5.
and 4.5, yeah? I think that it's going to go here and then have, so it's going to be like it's going to be like an odd powered function here where it's going to go down and then up and then down again. But it might curve back up over here. We're about to find out. I think that's what it does. Is that what it does? Did you already do it? Did you already do it? Yeah. Great.
Well, I didn't do it.
But you, yeah. 1.5. So we already know it goes down from the key. And let's pause with our usefulness, right? So this is what it's going to do, right? It's going to go here, here, and then here. Yes?
So
Yay.
wonky.
Let me put some emphasis on the syllable, also on the math. How did we solve this problem?
Putting in a
Plotted
point.
it. Plotted points.
We just plotted enough points to where we got an idea of what it looks like. We did our asymptotes, doing our asymptote methods, and then we just shove a bunch of points in there, right? So it's not hard, maybe a little tedious, right? You just gotta, go for it. And if you don't have, and we see the question answer process that's in our head when we do this. Like, okay, do these two dots give me enough information based on what else I know? No, yes, shove a curve on it. No, do more dots, right? That's the decision tree. That's the extent of the decision tree. Just think, next year when you do these problems, you'll be able to pop this out with the calculator.
What?
What?
I want one.
Yeah.
I thought it was nice, a little nice before, and now I think it's even nicer now.
What is
Yeah, right.
nice?
The graphing calculator.
The graphing, having a graphing
Oh.
calculator spit that all out.
Yeah.
Let's learn variation functions.
They're all pretty much the
Yeah,
same
because,
as we're learning.
Almost all class. I just got stuck for this one.
Yeah, I love how we spend our whole class.
Literally
doing
like
one
over
question.
half the class on that one problem. It's kind of fun.
It's kind of funny.
Because
Hilarious, Lynn. The most funny thing.
wait, is it 8-5?
Where is my, yes?
Yes.
Where is my, oh, there it is.
Who's texting you?
What is today? It's the first.
Is the thing still recording? Still showing stuff?
Move your head, Malcolm.
Yeah, it's moving. It's working.
Well, there's a delay, so it won't be like the same amount.
I just saw you moving. So.
You saw me moving. Well, there you go. Good job. All right.
You missed something.
Okay. Okay. So you have learned variation functions way back in the Algebra 1. But all we learned in Algebra 1 is direct variation. And the direct variation formula is y equals k times x, right? So k is the constant of the proportional constant, or the constant of variation, or any other number of names. What do they call it here? Constant of variation is what our book calls it. It's the proportionality constant or whatever else, right? So that's simple. When we're doing a direct variation problem, we're usually finding k and then finding something else. We'll do some examples, I promise, in a minute, but this is what you learned in Algebra 1. Okay, this much. So we're going to add two other types of variation. Joint variation.
Should we leave room to add examples?
If you want to organize your notes that way, you are welcome to do that. Joint variation, so that the words will be y varies jointly with x and z, or something along those lines. And it's going to be something like this: y equals k times x times z. So k is still the constant of variation. It's in each one of these types of problems, k is going to be a number. Very, very likely you won't know that number at the start of the problem, and that'll be your first task, is to figure out what k is. And then we're going to use the equation that we build with that to find the other things. So these are both multiplication. Varies directly and varies jointly. It's both multiplication. The third and final, I think, don't catch me lying to you. Yeah, third and final is inverse variation. Inverse variation is not multiplication.
Oh, you guys have division.
Wow, that's true. It is. And it is y equals k divided by x. So if the words say y varies inversely as x, then you'll use this form. And we'll do an example here in a second that combines multiple different things, where the problem might say y varies directly as x and inversely as y. And then you're going to build all this equation, right? So let's do a couple examples. Couple of three. We're going to do guided practice 2 on page 563. Actually, you know what? Let's do an easy one fast. Let's do guided practice 1. So if r varies directly as t and r equals negative 20 when t equals 4, find r when t equals negative 6. So this is a classic direct variation problem. You did ones like this when you were in Algebra 1. At least if you had my class, and you probably did it anyway, right? So if r varies directly as t, so the first thing we would do is write r varies directly as t, right? There's our generic start. R varies directly, right? Multiplication as t. So then it says that r equals negative 20 when t equals 4. And find a bunch of other stuff. So what we need to find is the very first thing we need to do is we need to find the constant of variation, which, like I said, is pretty much always your step number 1 on all of these problems, is we got to find the constant of variation first, and then we use it to do something else. So it says that r is negative 20 when t is 4. So let's solve for k. That's easy money. How do we do that? Divide by 4. So k equals negative 5. So our equation that we're working with is r equals negative 5t. Right? And then it says, find r when t equals negative 6. So what do you think you're going to do? Plug negative 6 in and then find r. So that's an F. R equals negative 5 times negative 6. So r equals 30. So this and this are the two answers to this problem. Done. Easy money. Right?
Oh, that's awesome.
Yeah, but here's my strong recommendation, boys and ladies. When you go to study for this test, don't skip studying this lesson because it's easy, because it'll all ooze out your ears on the day of the test. So spend at least a couple minutes studying this one.
Okay.
Spend the bulk of your time studying the hard stuff, but don't skip this, because I promise it'll ooze out your ears and it'll be like, oh my gosh, I thought I had this, and that's what will happen on the test, and then you'll cry and it'll be a bad day. So let's do problem guided practice 2 on the same page. Suppose r varies jointly as v and t. So what would our starting equation look like?
R equals K T
Vt. Yeah. Okay. So find r when v equals 2 and t equals 8 if r equals 70 when v equals 10 and t equals 4. There's a lot of stuff. They also kind of put it all in backwards order a little bit. In order to find k, which set of numbers do we need to use?
70,
The last 3.
The last 3, right? Because those are the only 3 that we have all 3 numbers, right? So we're going to use the last 3 numbers. Okay? So t equals 8. V equals... Oh, yeah. I'm reading in the wrong place. I think if I pick this up and hold it over here, I'll have better luck, right? Where am I? R equals 70. V equals 10. And T equals 4.
4. Oh, yeah, you're right. I was just thinking
So
dumb.
32K equals, no, not 32. I'm wrong. Aren't I? What is 16 minus 4 actually?
It's 10 minus 4.
What?
10. It's v equals 10.
10. 40. That's what I said.
Yeah, I heard it.
K equals 7/4. Great. Find R when V equals 2 and T equals 8. Is that what y'all got?
You're getting there.
Just show me your calculator. Or whatever.
I left my calculator at home again like a dummy.
Dummy. What I did though with my middle school skills was I pre-reduced, divided the 4 and the 8 by 4, and I got 1 and 2, and then 7 times 2 times 2 is 28.
Can't we just put that on the calculator?
Yeah, that's what I said. Way to go. Great. Let's do another one.
That was awesome.
That was awesome.
Why did the first one have 2 answers?
This also would have 2 answers. It would be R equals 7/4 VT.
Guided practice 3 now?
Probably. Because that's the equation.
The VT.
I don't know that the problem asked for that, but
Would it count out?
it depends on whether it asks for it or not. And I don't know that it does, but All right, let's do guided practice 3. If x varies inversely as y. So if x varies inversely as y, right? So the order matters on an inverse variation problem. And it says that x varies inversely as y. So it's kind of a left to right situation, right? Making sense? Good. And x equals 24 and y equals 4. Multiply both sides times 4. And we end up with what? 96? 96. So the equation we're working with is x equals 96 over y. And we want to, we found k and I just put k back in there.
My brain.
No, you're good. Find x when k, no. Find x when y equals 12. X equals 8.
Yay.
Great. Let's do guided practice 5. And then we'll write some homework and then get out of here. Well, y'all will get out of here. I'm stuck here.
Oh, that's it.
So sad. 5.
Oh no.
This is multiple.
We're throwing in another.
Combining them?
Yeah, I did explain that earlier, but y'all forgot to listen for that 30 seconds.
I think.
It's not scary. Suppose P varies directly as R and P varies inversely as T.
Which one is this? Joy?
You have to think of this like the formulas where you plug in numbers in your equation.
Over T.
Oh.
Oh.
Yeah.
Directly as R and inversely as T.
And inversely is T. I didn't see that part.
Yeah. Find T when R equals 10 and P equals negative 5. If T equals 20 when P equals 4 and R equals 2. So this is another one where it gives you the numbers backwards, right? We're putting the last 3 numbers in, right? So find if P equals negative 5, if T equals 20, and oh yeah, and R equals 2. K equals 40.
Now we just shove everything in there with
Which one are we calling?
10 and 5. Or negative 5.
I'm not hearing any red flags. Oh, it seems like we're doing okay. So P equals 40 times R over T. This type of problem, by the way, if you're going to see this in real life, it's probably in chemistry.
Yeah, that's what I was just saying.
Yeah. And this is very much a way you would understand, because you would want to see how quickly a particular reaction would change, like these and you know that as this one goes up, direct variation, the other one goes up. Inverse variation would be as this one goes down, the other one goes up, right? So that's very, very much.
It makes more sense.
Well, good. And it's also easy.
Well, it is.
So find T when R equals 10 and P equals negative 5. So negative 5T equals 40. So T would equal,
Wait, isn't it 400?
oh yeah, it is, you're right, equals negative 20. So I would almost guarantee you that if this was a chemistry problem, T is temperature, not time. because negative. Homework. What is 8-6? Oh, rational equations. So that likely means, what is today, Tuesday? The new lesson, the homework, whatever that. Yeah, cover new lesson, homework due Tuesday. Test will be Thursday.
Test will be this Thursday?
No,
No.
next Thursday.
Oh,
I was like, what?
you just almost gave me a heart attack.
No, we do this at home on Wednesday.
Both sets? We don't know what we're doing. Oh. Is that 5? Yeah.
Guten Abend.
Wasn't there a girl in our class last year that was wearing it earlier?
Maybe,
It is not afternoon yet.
but it's going to be.
It's going to be.
If I wish you a good morning, then that would be almost a waste because there's not much of that left.
It's true, but still.
So have a bad rest of your morning and a good afternoon.
Thank you.
Okay.
Did you say purpley bruise?
Yeah,
I got
your face got whacked in jujitsu.
I don't see a bruise.
my lip.
Oh yeah, barely. If you wouldn't have pointed it out, nobody.